we're looking at, our goal is I can simplify expressions as a single positive power. So what we're talking about when we're talking about a single positive power is I want my final answer to have one base to one exponent. Okay. Now, when we're simplifying, this sometimes creates an issue because if we take a look here, um, we might have to change a base to an alternative base in order to make that happen. And the way we do this is accomplished through our power to power law. And remember, power to power law is if I have a power to a power, I multiply my exponents. So let's take a look at, first of all, if I have a base of 125, if I can change that base to another power, another base. Now, obviously I can't change it to the base of 2. However, I could change it to a base of 5 because when I do that, what I'm ending up doing, actually processing, is that's the same as 5 to the power of 3. Okay, so 5 to the power of 3 is 125. So I could change this base to 5 to the power of 3. Now let's take a look at the next one. 625, what would that be as 25 to the power of something? Well, that would be 25 squared. Or I could also change the base of 625 to 5 to the power of 4. So sometimes we're capable of changing not to one base, but actually to two different ones. Okay, so let's look at some examples at what they're expecting us to do. Okay, so express as a single positive power. Okay, so if you want your communication marks, which all of you should want, it has to be a single power and it needs to, the final answer needs to be positive. All right, so when I first look at this, I can see my bases are all different. I have a base of 3, I have a base of 9, and I have a base of 27. So I need to change all of those bases somehow into one base. So the easiest thing to do is to look to see, usually it's a smaller number that I can turn the larger ones into. So the first one I'm going to look at is 3 squared. 3 squared is my smallest base, so I'm going to keep it the way it is. So back to the writing pen, where are you? Here you are. Okay. So I'm still going to have this, all of this top part to the power of 3, the numerator. So I'm going to keep 3 squared the way it is. Now 9, I can change it to a base of 3 because 9 is the same as 3 squared, right? 3 squared is 9. And that is also to the negative 2, so I must keep the negative 2 there as well. Then I'm going to look at my denominator. My denominator right now is a base of 27. Well, the base of 27 can be changed to 3 cubed, and you notice that it is already to the power of 3, so I have to put that back on, and all of it is still to the power of negative 1. So now what you can see is all of my bases are a 3. Now just be careful of the brackets and that you don't miss some of these exponents. So now it's just a matter of simplifying, using in most cases the power to the power law. So the numerator, I have 3 squared times 3 to the power of 2 times negative 2, which would be a negative 4. And in my denominator, I would have 3 to the power of 3 times 3, which is 9, times a negative 1, which would be a negative 9. Okay, so it's just a matter of going through step by step. All right, you can see that it's starting to get a little bit less complicated looking. Now, when I am multiplying and my bases are the same, such as they are here, I add the exponents. So on the top, I have 3 squared times 3 to the negative 1. When I add 2 plus a negative 4, I'm going to end up with 3 to the negative 2. and I'm going to leave my denominator alone. So we have one more power to the power at the top in our numerator, so that will become 3 to the negative 6 all over 3 to the negative 9. Now, when I divide, so in my head I'm thinking, okay, I'm dividing and my bases are the same. I know that I need to subtract my exponents. So that's going to be negative 6 subtract a negative 9, which is the same as negative 6 plus 9. So I end up with a positive 3. So that's what I'm going to end up with. I'm going to end up with 3 to the power of positive 3. Okay, now they don't ask me to evaluate. Evaluate would be taking my calculator and actually typing in 3 to the power of 3 equals, and it would tell me it's 27. So let's go back to see what if we have accomplished what they asked us to do. Well, do we have a single power? Yes, I have one base and it's 3. Is the power positive? Yes, it is. It's positive 3. All right, let's look at the next example. Okay, the next example, my bases are 32, 4, 8, and 4. So is it possible, because 4 is my smallest base, is it possible to change these other bases to the power of 4? Well, I know 4 times 2 is 8, but 4 to the power of 2 is not 8. So that means I cannot change my 8 to 4 to the power of something. And the same is true for 32. So that means that I'm going to have to change all of these bases to another base. Okay, well, what base can you change 4 to? Well, you can change it to a 2 because we know, and we're just going to put this to the side so we can actually see what we're doing. So I know that I can take my 4 and I can change it to 2 squared. I know my 8 is the same as 2 cubed, and 32 is the same as 2 to the 5th. So what I'm going to do is I'm going to replace each one of these bases with the new base of 2. All right, so let's get to it. And you notice we have a negative 1 out here. We can leave it there for now. All right, so 32 is the same as 2 to the 5th. 4 to the negative 1 is going to be 2 squared, all of that to the negative 1. And in my denominator, my 8 cubed is going to be 2 cubed, all of that cubed. And finally, my 4 is going to be 2 squared. And remember, all of that is to the negative 1. All right, so now it's just a matter of doing the power and to the power inside here to simplify. So we have 2 to the 5th. We have times 2 to the negative 2. And on the bottom, we have 2 to the 8th times 2 squared. And all of that is to the negative 1. You can see that now we have it much simpler in the sense that we have all bases of 2. So in that square bracket, what we're going to do, some people can do it all in one step. However, if you can't, that's fine too. So the numerator is going to be 2 to the power of, multiplying. So 5 plus a negative 2 is 2 cubed. On the bottom, I have 8 to add 2 is a 10. And I have everything to the negative 1. All right, when I divide bases, I subtract the exponents. So that's going to be 2 take away 10, which is 2 to the negative 7th. And remember, all of that is to the negative 1. Power to a power, I multiply, and so I end up with 2 to the power of positive 7. Okay, so step by step, change our bases. Simplify by doing power to powers, adding exponents if I'm multiplying, subtracting exponents if I'm dividing, and then seeing what I have at the end to see whether I have to reciprocate the base in order to get rid of a negative exponent, which we didn't have to do with our two examples. Okay, so there is a handout that you're going to be working on in class tomorrow. There is the second part of this video dealing with rational exponents. So a few different things. This just gives us kind of a background of how to work. So feel free to watch the next video.